Hello everyone and welcome back to this video on the CodeBakery. So in this video I'm going to be discussing the solution to Codeforces Round 656 Division 3 Problem E, which is called Directing Edges. So before you watch the rest of this video, I highly suggest all of you guys first read the problem statement, which I'll provide in the description below a link to, and attempt to solve this for yourself, or at least think about how you would do it. And if you guys are stuck and don't know how to solve this one, I would recommend watching a previous video that I've made on a similar topic for like Captain Flint and Treasure. And both of these questions use like the same type of idea. So if you don't know how to do this, I highly recommend first you guys watch this before trying to attempt to, first you guys watch the other video, which I will also provide in the link in the description below, and then try to solve it for yourself, and then you can watch the rest of this video. However, in this video I'm just going to be discussing the solution, so let's just get right into it. So the idea for this is, given a graph, we want to, it might already have some edges that are directed. We want to add some more edges that are also directed and will make the graph acyclic. So obviously, first of all, if the graph is not acyclic in the beginning, then we can't do anything and we'll just print out no. But if it is cyclic, or if it is cyclic, then we can't do anything, because then we can't add any edges to make it uncyclic or acyclic. But if it is acyclic, we will always be able to add edges such that it remains acyclic. So the idea for this is we're going to use topological sorting. So I discussed topological sorting in one of the previous videos, but I'll just explain it again. Topological sorting is essentially an ordering in a directed acyclic graph that we will never go from a lower node to a higher node. So for example, in this one, the topological sorting would be 1, 2, this one right here would be 3, and this one right here would be a 4. And as you can see, we're never going from like a higher node to a lower node. We're always going from like a lower node to a higher node. And I'll just quickly describe how we essentially implement it. I discussed this same thing in one of the previous videos, but I'll just do it again. So the idea is we first add all the nodes that do not have any edges going towards it. So in this case it's 1 and 4. We take the first node out of here, so 1, and we number this with the current number. So I'm just going to erase all of this right now. So the current like number, so that would be 1 right here, and I can just create a cur variable. So now it's like 2 because I already used the 1, and I will essentially remove all of the edges that go from that node to other nodes. So now this one doesn't exist, like we will pretend it doesn't exist, and then we will also add all nodes that no longer have any edges going towards it. So now it'll be 2. We take the next one right here, give it with number it with the current, so 2. This now increments to 3. We remove the 4 from here, and now we are going to pretend that this edge does not exist. We add the 3 here to the end of the queue now, because now 3, or actually we don't add 3, my bad. 3 still has this edge right here. So now we take the 2 from the queue and we'll number it with the current, so now it's 3, and now we pretend that this edge doesn't exist, and now we can add this 3 right here. So now we just take the 3 out because it's the only element in the queue, and we number it with the current. And I forgot to increment, but I hope you guys understand the point of topological sorting. And just saying, if there is a cycle in it, like for example, if it was like 1, 2, 3, like this, then what would happen is essentially these nodes would never be added to the queue, and these nodes would never be numbered. So when we do this, when we first do our first topological sort, we have to make sure that all of the nodes have a number to it, or a topological ordering to it. If some of the nodes don't have a number, then we would just print out no. We can't even try to add the undirected edges that they gave us. Alright, so I'm just going to add these back here. So now we have the topological ordering. So how do we add an edge? So for example, from this node 4 over here to this node 2 over here. So like I said before, in topological orderings, we can never go from a higher node to a lower node, or else we could potentially have a cycle. So they're going to give us like 2 nodes, and we see, okay, for these nodes, which one is the smaller topological ordering and which one is the larger topological ordering. And then we're essentially just, I accidentally put this the wrong way. It's like that. So we're going to see which one has the higher topological ordering and which one is the lower topological ordering, and we're just going to connect it from the lower one to the upper one. So then this one right here would be like that. And now, as you can see, we still don't have any cycles because it maintains this topological ordering. If, for example, we were going to go from 3 to 2, in this case, we actually do not have a cycle, but this is not always guaranteed. So, for example, if I wanted to do it from node 3 and node 1, if I were to go from the higher topological ordering to the lower topological ordering, we would have a cycle, because I can go from 3 to 1, 1 to 2, and 2 to 3. But I want to maintain the topological ordering, so I go from lower node to upper node, and as you can see, there's still no cycle. So yeah, essentially the algorithm is do a topological sort, and I hope that you guys understand how you can do the topological sort. And you guys can also see a previous video that I did that I covered this topological sorting, and I also provide a description or a link to topological ordering in the description below. But you topological sort all the nodes, and you see if any of them do not have a number or an order associated with it. In this case, that means that there is a cycle and we just can't do anything, so we'll print out no. And then after this, we're essentially just going to, for every 2 nodes, connect from the lower one to the upper one in this directed fashion. So thank you guys for watching this video on the Code Bakery, and I hope that you guys can watch other videos too. Thank you and goodbye.